The hallmark of our Flame project is a notation for expressing algorithms that avoids indices. Those of you who have some experience with programming know that many programming errors, also called bugs, come from errors when indexing into arrays. So, a notation that avoids indices potentially allows you to avoid programming bugs. The notation builds on what we just learned about blocking vectors and how this relates to the dot product of two vectors. Let's recall how we march through vectors when computing a dot product. Here is how we can express an algorithm for performing the dot product using these insights. First, the routine is called dot. It takes as input two vectors, x and y, and returns as output alpha, the dot product of x and y. Initially, the vectors x and y are partitioned into top parts, x top and y top, and bottom parts, x bottom and y bottom. In this algorithm, the top parts track the parts of the vectors with which we have finished. The bottom parts track the parts with which we have yet to compute. So, initially the top parts have no components in them. We also initially set alpha to 0. Now, we check whether x top is the whole vector x. If so, we have computed with all of x and are done. If not, then we repartition the vectors, renaming the top parts x0 and y0, and partitioning the bottom parts into the first elements, chi1 and psi1, and the rest of these parts, subvectors x2 and y2. In this iteration, we now multiply the exposed elements chi1 and psi1 and add them to what is currently in variable alpha. We are then finished with chi1 and psi1, so we add them to x top and y top. Notice how the thick line has meaning. It tells us how x0, chi1, and x2 are part of x top and x bottom, and how y0, psi1, and y2 are part of y top and y bottom. Now, we go back to the top of the loop and again ask the question whether x top is all of x. Eventually, we will have processed all of x and y, the loop finishes, and alpha contains the dot product of x and y. Let's see how this algorithm computes the dot product of our two vectors x and y of size 5. First, x top and y top are empty and alpha equals 0. We expose the top elements of x bottom and y bottom, calling these chi1 and psi1. We multiply these exposed elements together and add them to alpha. Then the thick line moves, making what were the top elements of x bottom and y bottom now the bottom elements of x top and y top. We expose the next set of top elements of x bottom and y bottom. We multiply those together, add them to alpha, and we move the thick line forward. And we keep repeating this. At this point, the inner product has been computed and the algorithm finishes. What is important here is that the algorithm views vectors as regions. This helps us think of regions of vectors when we learn more about how to perform operations with vectors. Later, we will learn how to turn these algorithms into Python code.